Hello, my name is Arham Tafim, and today I would like to talk to you about the main class in our Flappy Bird project. So the main class, it implements the action listener and the key listener events, the interfaces. So the action listener interface is the listener interface for receiving action events. The class that is interested in processing an action event implements this interface, and the object created with that class is registered with a component using the component's addActionListenerEvent method. Whereas the key listener interface, it uses a keyboard event which is then generated when a key is pressed, released, or typed. The relevant method in the listener object is then invoked. This is used to implement the spacebar tap, so that when we tap the spacebar, the Flappy Bird will jump. So here we have listed down a few in variables such as the screen width, screen height, pipe gap, pipe width, bird height, update difference, X movement difference, screen delay, bird location, and the bird jump diff. So the main ones that you need to know, which is the screen width and the screen height, which is the width and height of the screen of our game. We also have the pipe gap, which is the gap between the pipes so that for the bird to go through. We also have the pipe width and the pipe height, which is to determine the width and the height of the pipe. We also have the bird width and the bird height, which is the width and the height of the bird. We also have update difference, which is used to declare the time in milliseconds between updates. And we also have the X movement difference, which is the distance the pipe moves every update. We also have the screen delay, the bird X location, and the bird jump diff. We also have a few Boolean variables that we need to be declared, such as the loop var, which is to declare whether the loop is being run for the pipes. We also have the gameplay variable, which is to declare whether the game is being played or not. We have the bird thrust variable, which is to declare whether or not the key has been pressed for the bird to jump vertically. We also have the bird fire variable to identify whether the button is pressed before the jump completes. We also have the release variable to declare whether the spacebar has been released. So it starts as true, so the first press registers. So here we have declared jframe_f as a variable, so that we can create a new jframe with the title Flappy Bird OOP January 2023. We also created a J button for the start game button, so that we can press the button to start the game. And we also have the J panel top panel. So here we have our public main and the public static void main. And here we start to build the GUI on a new thread, and also start the sound when the game is played. We also have the run method, so that it can create a new thread to keep the GUI responsive while the game runs. And here we can also declare whether the game screen is splashed is true or not. So here we have the build frame method to declare the image icon for our Flappy Bird, as stated here, resources/bluebird.png. And here we have all the properties of the Flappy Bird, so that we can suit the Flappy Bird's size and the visibility so that it can stay in the screen, so that you can see the Flappy Bird on the screen. Here we have a J panel, create content panel, which is the top panel here. Top panel. We set the background and the set layout for the overlay. And here we have the start game button, which is here. See, you can see start playing here, so that when we press the button, we can start playing. And here are all the properties for the button, such as the color, the font, and the alignment. And we add the action listener, so that when we press the button, the game will actually start. So here we have the action form method, which implements the action event listener, so that this method will be used so that to declare when the button is pressed, the splash screen will stop and the game can actually start, as stated here. See, loop while true and the game play true, and also here t.start. So here is the key press method, which involves all the variables which involves all the situations when we press the key in our keyboard. So for instance, when we're talking about the VK space, which is the space bar, this is to indicate that when the space bar is pressed, then it is used to register the bird jumping. For here, when we talk about VKB, which is the B letter in our keyboard, this is used to restart the game when the gameplay is over. So let's say when we hit a pipe or when we fall down to the ground, then we need to press B to restart the game. So this is where we have stated here. And for here, VK escape, which means the escape button in our keyboard. When we press the escape button, the system will exit. This method is the key release method. So this is just to register when the spacebar button is released, so that we can say that release is true for the logic variable. So for the fade operation method, this is the method that initiates the variables and the coding for the fade that happens before the start of the round. So when the game starts, or when we restart the game, before starting the round, before starting the gameplay, there will be a fade where the screen turns to black and it returns back to the gameplay. So this is all the coding that we have used to make that happen. So the method game screen, this is used to initiate the pipes and the Flappy Bird, which basically is the images into the game, so that we can declare where the pipes will be and where the Flappy Bird will be placed in the game. So this is all the coding for it. Next, you have the method bottom pipe lock, which it randomizes integer value for the bottom pipes placement, so that it randomizes a value for where the bottom pipe will be placed, which in return also creates the pipe gap and also the placement for the top gap. For the top pipe. So it will all be initiated here. This is the method update score, where it updates the score every time we go through the pipe, so that when the Flappy Bird doesn't hit the pipe and it goes through the pipe, the score will be updated. It will go up to 1. It will increase by 1. Sorry. Yeah. And here is the method collision detection, so that this method is used to initiate coding for whenever the bird will hit the pipe. The collision detection will be used to declare whether the bird has hit the pipe or not. Wherever it's the top half of the pipe or the bottom half of the pipe, this collision detection method will be used to notify us when the bird has hit the pipe, so that the gameplay will end. This method collision helper is also an extension to the collision detection method, where it helps us to detect whenever the collision between the bird and the pipe is created, so that it can send the text game over and the gameplay will be ended. So that is all for the main class. Thank you.
Hi, hello. My name is Sarif, and I will be presenting about the top half class. So first, as usual, we declare the top half class and put all of everything inside. We did the variable top pipe with image as its type, and then we also declare the variable x location and y location integer, which we set as 0. First we did the top half constructor with initial width and initial height as its parameter, and then we did the method for scale top pipe, initial width and initial height as its parameter. Integer width and integer height is as its parameter, so that we can get the desired size of this top pipe. Next, we did the method to get the image for the top pipe object. For the top pipe object, and then we did the method for get width and also get height, so we can get the dimension of width and height, and we can return this integer. Next, using the variable that we have declared earlier, x location, we set the coordinate for zx and set the getx for the top pipe object. Next, we also use the y coordinate with y location, integer y as its parameter, set y, and we also did get y for y location, and we also did the outline with public rectangle, get rectangle, which we return the rectangle and as y location and y width and height as its parameter. And lastly is the buffer image, which will then return the top pipe image with everything completed. We use the buffer image get bi, which stands for buffer image, and then lastly we return buffer image, which will then finally return the top pipe image for us. That's all from me. Thank you.
So hello everyone, this is Onula Memon. I, with my teammate Noor Ainin Sophia, will be presenting the code for bottom half class, which is compiled in Java. This class is part of a larger program that involves a game where the player controls a character that must avoid obstacles. So let's take a closer look at the code. The bottom half class has several instance variables, including an image object called bottom pipe and two integer variables for the x and y location of the image on the screen. Moving further, the constructor for this class takes two integer parameters that represent the initial width and height of the image. Inside the constructor, we initialize the bottom pipe image using the toolkit class and the getResource method to load an image file. We then call a method called scaleBottomPipe to resize the image to the desired dimensions. The scaleBottomPipe method takes two integer parameters for the new width and height of the image, and it uses the getScaleInstance method to create a new image object with the desired dimensions. So further of that, my teammate will explain first.
Okay. For the bottom half, class also has a several getter and setter method for accessing and modifying the image location and also dimension. So for example, we have the getWidth, getHeight method return the current width and height of the image respectively. So now we have the public image getPart, which is return the bottom part. So and we have public void set x for the x location, then get x to return the x location, public void set y to read for the y location, also get y to return the y location. So for the get rectangle method returns a rectangle object that outline the position of the image on the screen, which can be useful for the collision detection. And finally, we have the public buffer image getBI. So the getBI method returns a buffer image object that represents the image. So this method is used to draw the image onto the screen in the main game loop.
Hello, my name is Ahmad Lutfi, and today I will be explaining the character class in our project. So the character class represents the Flappy Bird object character. This class also contains several methods that we use to manipulate and also obtain information about the character, that is the Flappy Bird. So first we will take a look at the variables that we declare in this class. The first one is Flappy Bird. Flappy Bird is an image representing the Flappy Bird's image. Next we have the x log and y log. It is an integer variable that represents the x and y coordinates of the bird on the game screen. In the constructor, we have two parameters, that is initial width and also initial height. It initializes the Flappy Bird variable with an image of a blue bird from a file named blue_bird.png in the resource folder. This is the image of the blue bird. Next is the scaleBird method. The scaleBird method can be used to adjust the size of the Flappy Bird image by scaling the image to whatever dimension that we want to use. Next is the getBird method that returns the Flappy Bird variable, while the getWidth and also getHeight method returns the width and height of the Flappy Bird. These methods can be used to determine the dimension of the bird object for detection of the pipes, these pipes. Next is the setter and getter for x and y. So set x and also set y method sets the x and y coordinates of the Flappy Bird, while the get x and get y method returns the current x and y coordinates of the Flappy Bird. Next is the get rectangle method. The get rectangle method returns a rectangle object outlining the position of the bird on the game screen. This can be used for collision detection with other objects in the game. As I mentioned before, this will further be explained on the top half and bottom half of class. Lastly, we have the getBI method. The getBI method returns a buffered image that represents the image of the Flappy Bird that we use, and this method can be used to draw the Flappy Bird's object onto the game screen using the graphic objects provided by the game rendering engine. That is all from me. Thank you, and I will pass on to the next class.
Hello, my name is Farah Fuad. Today I'll be presenting our object-oriented programming project, which is the Flappy Bird game. The code we will be representing is written in Java fully. So I'll be presenting the game screen class. So this class has several variables, including the screen width, screen height, display, successful jumps, message, primary font, field font, message read, score read, BP1, BP2, TP1, TP2, and bird. So I'll get into detail of the function for each variable. So screen width and screen height variables hold the dimension of the game window, and then is splash is a Boolean variable that indicates whether the game is in the splash screen mode or not. And then successful jump holds the number of jumps made by the bird. So when the user play the game, every obstacle, which is the pipe, if they get through the pipe, they will get a point. So that is the function for successful jump. And the message holds the message to be displayed on the screen. And then primary font and field font variable is to hold the font for the message. As you can see here, this is the font for field font. And then primary and the message read and score read, they hold the width of the message and score. And then BP1, BP2, TP1, TP2 are objects of the bottom half and top half classes. And lastly, bird, it represents the character class in the game. And then in this game screen class also has several methods, including the paint component, graphic G. So this method is called every time the screen needs to be updated. So it draws the background, pipes, bird, and score on the screen. Next is the set bottom pipe. So basically, set bottom pipe is the method where it set the global bottom pipe variable, which is the BP1 and BP2. Same goes with set top pipe. It set the variable of TP1 and TP2, and also same goes with set bird. It set the bird variable. And then next is the increment jump. So this method increases the successful jumps variable by 1, and as I said before, when the user get points when they get through the obstacles, which is the pipe, they will get a point. So each pipe will have 1 point, and then their points will keep on increasing. And then get score. So get score is the method where it returns the current value of the successful jumps variable. And then send text string message. So this method sets the message variable to the given string message, such as Flappy Bird or game over, something like that. And then for testing, for example, we can set the message variable to game over using the send text method and verify that it is displayed correctly on the screen using the point component method. So this testing will be held on the main class, which will be presenting by my other teammate in detail. And then if we take a closer look at this class, there is some of our principles present in this code, which is first is encapsulation. So in this code, the game screen class encapsulates various attributes and methods, including the screen width and height, the current score, and the bird, and also the pipe objects. And then we have also abstraction. So it is where the game screen class abstract away the details of the game's graphic by providing a simple method such as the paint component, and also that takes care of all the drawing operations. And then the next one is inheritance, where the game screen class inherits from the J panel. So this is the code where the inheritance occur. It is where they provide basic functionality for creating a GUI. And then the last one is polymorphism. This is where the game screen class makes use of polymorphism by allowing different types of pipe and bird objects to be passed in and drawn on the screen. And I think this is the end of my presentation. And now I will pass the presentation over to my other teammate who will be presenting the next class. Thank you.
So now I'll be presenting code for Java class called sound. This class is responsible for playing audio files in this game. So taking a closer look for the code, the sound class has one method called play music that takes a string parameter representing the file location of the audio file to be played. Moving further, inside the method, we create a file object with the specified file location. We then check if the file exists using the exist method of the file class. If the file exists, we use the audio system class and the get audio input stream method to create an audio input stream object from the file. We then use the get clip method of the audio system class to create a new clip object which is used to play the audio file. We call the open method for clip object to prepare the audio file for playback, and then we call the start method to begin playing the file. If the file does not exist, we print an error message to the console. If an exception is thrown at any point in the method, we cache it and print the stack trace to console for debugging purposes. So that's all from my side.